So I've been asked by a bunch of my Patreon to start explaining how to build a math from the beginning. And a lot of people were feeling like they're joining a meeting that was 3/4 of the way through and they're trying to play catch up. So because I got a lot of new Patreon, I decided to start again from scratch. I'm making the first video here on YouTube to let everybody know from the community. And then I'm gonna start posting it on Patreon after that, the rest of the mini-series. It's gonna go pretty fast and furious. I'm probably gonna be putting out a bunch of small videos so it's easy to understand, and we're gonna make our way from basic understanding of it with very little need to know anything about anything. And then we're gonna go through all the way up to the Nexian at the end and the different wave type and everything else. And also we're going to be touching on some more of that long video. So this little first video is just an example. It's just a start. Okay. Don't fret about anything. If stuff don't make sense, it's not a big deal. You don't have to memorize anything. I'm not going to teach anything in particular to build in this video. I'm just going to go over the components, what they're called, how we're going to build it, and the basic principle of what we're trying to do. Okay. So just sit back, relax, enjoy, and don't try to memorize anything. We're going to keep repeating ourselves, and we're going to go over the stuff over and over and over again. Let's make this fun. On the basic components of a PEMF. So basically, there's three parts in a PEMF. There's the power supply. There's a PWM. And there's a coil. Now, if you got these three, you can create a PEMF. Now, the quality of the PEMF will depend on how well you match everything for your need. So this little series, we're going to start nice and slow like this, and then we're going to upgrade until we get to the Nexian, for example, with all its intricacies inside. The idea is always to start slow. Okay, so first of all, we need a power supply. There's no ifs or buts about it. There's always information giving on the power supply, and you can enter that in the calculator, and then we can go from there. I like to design my coils and what I want to do, and then build it backwards the other way. But for right now, let's just start with this. So this one is 4.6 amps, and it's a power supply for a laptop, so it's 19.5 volts. 4.6 amps, 19.5 VDC, and then we punch that into our calculator. The ZK can take up to 30 volts and 8 amps. That's the maximum it can take. Well, this power supply is well within the limit of what the ZK can do. And then we have our coils. Now, you got all different kinds of coils. Patreon, we're going to be talking about these little guys that I just got in the mail there. We're going to take them apart and stuff, and we're going to see what's more detail coming up. So, your coils, you always want to make them out of magnet wire. The reason why you don't want to use wire like this is because there's so much insulation on that. You want your wires to be as close as possible together. Now, I know this looks bare to you guys. It's not. There's a varnish on top of that. There's a thin layer of insulation, and you have to sand it off, burn it off to make your connection, because there's insulation right now. Okay, then you want to tape them nice and tight, and there's many videos on that and stuff on the Patreon too, and you want to make them nice and tight. And then after that, what's really important, when you make your connection with these guys right here, you make your connection, and then you tape it back, and you leave just the flexible wire on the outside. So when you go from one coil to the next, you got a long connection like that goes between coils basically. So when you fold your mat back and forth, you don't break this wire.
magnet wire does not like to be bent over and over again at the same place. It just breaks. So that is the basic understanding of it. Power supply, a PWM, and then a coil. Now, I'm doing this video series just to remove the intimidation of building a system like that. And also, starting nice and slow like this, you can upgrade to a different system after without wasting your time, and it'll just be simpler and more fun anyway. So I would highly suggest you follow my instruction about the building the coils, and then you build 10 of those, and then they'll be good forever. There's no ifs or buts about it, okay? And then we'll talk about the coils later. Now, the way to wire this, well, you got your outlet power supply that comes in to your 120 volts. Oh, side bracket. These power supply, the plug-in at the end, they change depending on the country. They're rated to be inputted with as low as 100 volts as high as 240 volts. And no matter what, you'll have the same voltage coming out of the other end, okay? So it doesn't matter where in the world you live, laptop power supply will work. You just need to match the cord end with that, okay? And the reason why I use laptop power supply is because there's a lot of them. They're everywhere, and it comes in all different shapes and forms, okay? And I'll show you guys the one that I use after. Now, what you got to do with the cord end is you got to cut it off and then expose the wire. So then you're going to have your wire coming in to the ZK. Now, if we turn the ZK over, you see that there's 4 screws. There's the plus and the minus. So one will go there, then one will go here. From your power supply, this will be your plus, this will be your minus, right? And then the out, you have a minus and the plus on the out, but I wouldn't worry too much about that, okay? Because on a coil, if you reverse the plus and minus, you just reverse the north and the south. So you place the coil this way or this way, you wire it one or the other, it doesn't affect anything. We still have to balance our coils after that. And then out of the out, you literally go into your coil. In this case, we only have one coil, but that's okay. That's just what we want to do. So in a nutshell, this is a PEMF right now. If we were to wire that up, plug that in, put this power supply, cut the wires off, expose them, put them in there, and wire them up to the coil, we would have a PEMF. The way I like to do this, okay, a lot of the power supply come in this way, where one of the wire is the outside one, so you just twist it up. So this will be your negative. I'm 99.9% sure. This one will be the positive. So you got your positive and your negative in here, and you put that in there. And at that point, we would have power to this guy. And then you put your coil into the out, and then your PEMF is up and running. Now, the problem with that is the Ohm's law. Right? Like at that point your Ohm's law will be all messed up because you don't have a lot of resistance here, you got too much resistance, nothing is balanced, right? And that's why you need to go to the Patreon. You can join for free, get the calculator, and then the calculator will help you do that. Let's move on to the calculator quickly. Okay, so let's enter the data into the calculator. It's 19.5 volts, 4.5 amps. We're going to use 22 gauge, one coil, 95 and 95. Now, as you can see, if we were to wire that up, right, our power supply could not maintain that because that would kill it.
Now I want to open up a bracket while we're talking about this. Somebody asked me, it was a really good question, because we're going to cycle it at, let's say, 1% or 5%. Could he do it? Yeah, you're right, it could do it, and it would not kill the power supply because it's such a low amount of heat that it would have to create for such a short amount of time. If you left it on all the time, the power supply would only giving you this much available power anyway. It would not give you any more, but you're asking for more. So the crux of this is this: your Nexion, if your power supply also supplies a Nexion, you would burn it because you'd be under voltage, because every time it pulses, the voltage drop would go almost to zero, which makes the amperage go almost to infinite. And just bear with me, it's the way it is. You don't want to do that. You want to keep that at 80% so you don't kill your Nexion. I'm going to show you what would happen. You'll see the ZK will be pulsing.
Okay, so now, by the way, when you get your ZK right out of the box, it'll be at 50% duty cycle and 1000 hertz. The 1.000 is 1000, right? So bring that frequency back down to 1. Some ZK go to 0, right? Leave the duty cycle at 50, and then I got the on-off right here. Do you see how it goes off? You see how my ZK goes off, right? Even if I bring the duty cycle way down, the capacitors inside may not be able to do it. Okay, in this case, they keep up. Now the problem with this is as the duty cycle goes up, there's not enough power in my power supply. See? Bam. Comes back. Bam. Goes off. Comes back. Bam. Okay. So if that happens to you guys, while you got the Nexion hooked up to this system and you don't line your things up, you're going to blow your Nexion. Okay? So this is what we need to appease the Ohm's law.
Okay, this is the end of the first video of this mini-series. I'm just doing that to introduce it to everybody. I am taking a mini break from the YouTube. The last video I did took nearly 500 hours of working around, and it's too much. I don't want to do that kind of stuff. I mean, it was a good video. I love it to bits. If you haven't seen it, go see it. It has a ton of information, like really good stuff that you're not going to see anywhere else. But the Patreon is so much easier. Editing, filming, it just flows, right? So I'm moving over there. I'm going to go hide over there for a little while. There's going to be a ton of mini videos that I'm going to make, like this one, and we're going to go down the rabbit hole with building a PEMF. I have a lot of new Patreon that just basically are requesting that, and I thought it'd be a good time to review all the data and bring up to speed everything. On top of that, my frequency train is very well happening, and the Patreons are on top of that, obviously. Let me show you what it looks like. This is the frequency train. So we have a bunch of wagons, and then the train pulls it. You enter the frequencies for each wagon, how many seconds you want that frequencies to go, the duty cycle, if you want a unipolar or bipolar, and then you enter how many time you want that train to go back around. So usually you'll have like 5 frequencies of 1 to 5 seconds each, repeated like 500 times. Then it'll go to page 4. It'll tell you, okay, this session total time will be this much. Is that good? It's going to give you an option to save it, so you can have it saved and one of the 4 saved. Then next it's going to go and start, and then it's going to do it, and then you'll be able to turn the screen off. Right now I'm learning to do the programming with basically saving and the recall. So I'm working on those pages right now. So the Patreon, yeah, I already got some volunteers to try the program. But this is going to be pretty amazing, and this is going to get added to the rest of the program. So basically when you click on the advanced setup, you're going to get to the frequency train. And there's a couple more surprises that I want to show the Patreon. I'm building this page right here so we can have some fun with it. Anyway, come join us on Patreon. We're having a lot of fun. I make a lot of funny videos. Not necessarily haha funny, but you know. And yeah, we'll see you guys there. Talk to you guys soon. Be safe.